Hello students, in this video we'll see an example of how to use a Riemann sum to evaluate a limit. Let's find the limit as n goes to infinity of 1 over n plus 1 plus 1 over n plus 2 plus all the way down to 1 over 2n. So I'd like to find the limit of this sum over here. And so the key thing to realize is that this limit is not going to be 0. Even though if I did the limit of each of these terms individually, I would get 0. I have n of these terms, and n is getting large itself, so I'm having an infinite number of zeros adding up. In fact, each of these terms over here are bigger than 1 over 2 to the power 1 over 2 times n, because that's the largest in the denominator, so that's the smallest fraction. So if each of these n terms over here is bigger than 1 over 2 to the n, I have n of those things, so I'm going to have n over 2 to the n. So in other words, this sum is going to be larger than a half. So it's not going to 0. It's going to be something bigger than that. Okay? Now, to evaluate this limit, what I'm going to do is I'm going to remind ourselves the definition of an integral. Recall that the integral from a to b of f of x dx is a limit of sums. It's the limit, as n goes to infinity, of the sum, j goes from 1 to n, f of a plus j times b minus a over n times b minus a over n. And remember, it's the constant incrementation, right? I go from a to b by what? By steps of what? The step size over here is delta x, and that delta x is a b minus a over n. And so with the jth one of those things, is just going to be a plus j times b minus a over n. So make j steps, you're going to line up at that point. So over here you have your what? So over here you have your height, you have the length of the base, and over here you have the height, and that's going to give you an area. And as you take all these little areas and add them up, you get the integral. Okay, so now we can look at our sum from a different perspective. We can say our limit is really what? If I have 1 over n plus 1 plus 1 over n plus 2 plus 1 over n plus n, which is 2n, I can write this as what? As the sum, j goes from 1 up to n, of 1 over n plus j. Okay? And now what I'll do is I'll modify this sum a little bit by multiplying the top and bottom by 1 over n. So I'm going to do a 1 over n in the numerator. I'm going to do a 1 over n in the denominator. And so what that will turn our sum into is it'll turn into this. Turn into the sum, j goes from 1 to n, of, let's do the denominator first. I'm going to have a 1 over, n times 1 over n is 1. And then I'm going to have a j over n times 1 over n. Well, this is great because I think now that this looks like a limit, like a term in my Riemann sum. So it looks like my function over here, if I look at this carefully enough, it looks like if my a was chosen to be 0 and my b was chosen to be 1, so if my b is 1 and my a is 0, this would be a 1 over n. So I'm going to look at that choice. So let's make that choice clear now. So I'm going to if I let a be 0, b be 1, and f of x be 1 over 1 plus x, then with this choice of a, b, and f of x, what would this look like? This is going to be an f of what? F of j over n. And f of j over n is what? 1 over 1 plus j over n. That works. And if b is 1 and a is 0, that's going to be 1 minus 0 over n. So that's exactly what we have. So it turns out that the limit, as n goes to infinity, of our expression, the sum, j goes from 1 to n of 1 over n plus j, is exactly equal to the integral from 0 to 1 of dx over 1 plus x. We know how to integrate that. That's just the natural log of 1 plus x, evaluated from x equals 0 to x equals 1. The natural log of 1, the bottom limit is 0, because the natural log of 1 is 0, and the top is the natural log of 2. So the limit of our sequence is the natural log of 2. So using Riemann sums, we were able to compute this limit. Thank you very much.